Okay, guys, if you want to follow along in your notes, we're talking about exponents today. And look on the wire so you know what page number the table of contents goes on. So here we're doing exponents. You've seen it before. And remember, exponents is just repeated multiplication with the same number. So, for instance, if we have 4 times 4 times 4, that is really saying 4 to the third power. Okay? This x is called the base. This is our base, and n is the exponent. Okay? So this whole part makes up the exponential notation. X is called the base, n is called the exponent, and we read that as x to the nth power. And we have two different types of notation that we use. We've got expanded notation, which is where we just go 11 times 11. And in exponential expression, the reason I'm calling it an expression is because there is no equal sign. Okay? So this would be read 11 squared. And the value of that is you're actually doing what is 11 times 11. And 11 times 11 is 121. I'm going to jump down and have you take a look at number 3. This says negative 5 times negative 5 times negative 5 times negative 5. So what that's really saying is negative 5 to the 4th power. The reason I have to include parentheses around this negative 5 is because it's saying a negative times a negative times a negative times a negative, which we know is a positive, and 25 times 25 is going to be 625. So negative 5 to the 4th power is 625. Here on number 4, exponential expression would be 1/4 raised to the 3rd power. So we have 1 over 64. All right, so that should take you, well, actually, let's take a look at number 6 while we're here. We have 2 different integers going on. I'm going to include those negative integers inside the parentheses, so I get negative 2 cubed times 8 to the 4th power. Okay, so that's what that looks like. And I'm going to cheat real quick, and it's going to be negative 32,768. So if I actually wrote that out, I know it's going to be a negative integer because I have a negative times a negative times a negative, which creates, it's still a negative number, and then multiplied out would be negative 32,768. So that's going to get us through our first page of notes. If you flip over to the back side, we're going to talk a little bit more about exponents. And if you have questions on any of these examples, come see me in class and we'll talk about them. But right now, let's go over with the 0 exponent. I know you've been exposed to exponents before in the past, so I want to make sure that we're still good to go. 0 exponent may be a little new. So anything to the 0 power is 1. Okay, which doesn't seem to make a lot of sense, but we'll talk about why that happens in a second. So 1 to the 0 power is going to be 1. 2 to the 0 power is going to be 1. 3 to the 0 power is 1. So you can see my pattern here. Anything to the 0 power is 1. Okay? All right, my negative exponent rule, the format for this, if you have a negative exponent, we are going to flip our reciprocal and make that exponent positive. So I have 1 over x to the nth power. So I'm flipping my reciprocal. So imagine I'm making it into a rational form, so anything over 1. I'm flipping my reciprocal, and that negative exponent now becomes positive. Okay? So format-wise, it would look like this. I put it over 1. I flip my reciprocal, and I make my exponent positive. And it becomes 1 over 25. So 8 to the negative 2 power is going to be, put it over 1. I flip my reciprocal, 1 over 8, and that exponent becomes positive, and I get 1 over 64. Let's talk a little bit about why that happens. Can you see me if I go over there? All right. Actually, I'm going to move me. All right, and let's talk about why that looks like that. All right, so the reason it's looking like that is because if I have 5 divided by 5, what is 5 divided by 5? 1. anything divided by itself is going to be 1. 10 divided by 10 is 1. A million divided by a million is 1. 5,000 divided by 5,000 is 1. Even x divided by x is 1. X goes into itself 1 time. So anything goes into itself 1 time. All right, so how do we get these negative exponents? Well, if I have 5 over 5 times 5 over 5, which is really 25 over 5, but if I broke it down into prime factorization, I have 5 times 5 over 5. And I can reduce this fraction. My 5's cancel out to leave me with 5. Really, if I was in exponential notation, this says 5 squared over 5. 5 squared over 5, this is 5 to the first power. I could subtract those exponents, and 2 minus 1 gives me 1, which is just 5 to the first power, which is exactly what it was up here. Okay, so this is kind of the pattern that it looks like. So whenever you have exponents and you have division, you're really subtracting those exponents. So let's take a look. If I have 10 to the third power over 10 squared, this is really saying 10 times 10 times 10 over 10 times 10. Anything divided by itself is 1. So my 10's cancel out to be 1. My 10's cancel out to be 1. And I'm left with this 10 up here. Well, a shortcut to that would be subtract my exponents. 3 minus 2. What is 3 minus 2? If my base is the same, I subtract my exponents. So 3 minus 2 is 1. 10 to the first power and 10 to the first power, which is just 10. Okay? So what about those negative exponents? What does that mean? Well, if you have 5 to the third over 5 to the fifth, if I wrote an expanded form, that would be 5 times 5 times 5 over 5 times 5 times 5 times 5 times 5. I'm going to reduce out, so 5 divided by 5 is 1. They cancel out. These guys cancel out. These guys cancel out. And it cancels out to be 1, so really there's an understood 1 as my numerator. So I get 1 over 5 squared. And 1 over 5 squared is 1 over 25. But let's go back to the original rule. If I subtract my exponents when my base is the same if I'm dividing. What is 3 minus 5? That would be negative 2. So this negative rule that we just talked about means that you've got more 5's as the denominator. So that's why we get flip your reciprocal, 1 over 5, and make that exponent positive. So that's just an explanation as to why we do that. Okay, so now I'm going to take you back over to your notes page. So come with me over here. All right, and so that's your explanation. If that's too much, that's fine, but the more knowledge you have, I think, the better. So over here, my bases aren't the same, so what I'm going to do is, so for number 21, it's going to look like 1 over 4 cubed times 1 over 7. So 4 to the third power is 64. 1 over 64 times 1, 7. And I'm going to cheat and look at my notes, and I'm going to tell you that it is 1 over 448. So you piece them together, and then you multiply normally like we would on those fractions. So take a look at number 25. I have x to the negative 9th power. All that means is I have more x's downstairs. 1 over x to the 9th. It still becomes positive. Okay, a to the negative 4th. Put it over 1, flip my reciprocals, and my exponent becomes positive. Okay, let's do a couple more together, and then I'll let you go on your own. All right, so here we go. Let's take a look at number 27. R to the negative 6th power. I'm going to put these all over 1. The only one going downstairs, when I flip my reciprocal, is R to the 6th is going to become positive. R to the 6th. This 0, anything to the 0 power, remember, is 1. So really, he cancels himself out. And t to the 11th stays where he is. He's not negative, so he's going to stay. So I get t to the 11th over r to the 6th. Okay, so this is a video that I want you to watch because we did rockets today in class. So watch this and then make sure there's a little bit of understanding when you come to class tomorrow. That's when we'll do the homework and we'll go into our next section. If you want to get ahead anyway, come into tutoring anytime at 7:45 to 8:15, and I'll be more than happy to help you. All right, guys, I hope this video helped. See you tomorrow.